Hey folks, this is Nick from First Coast Math Clinic. In this lesson, we're going to talk about how do you factor the difference of two squares. We're going to look at these 7 examples. We're going to figure out how do we identify whether or not we have the difference of two squares, and we're going to come up with a specific rule that we can use to factor the difference of two squares. All right, let's get into it. So for our first binomial, we've got 4x squared minus 9. So let's look at this example. So the first term in our binomial, we've got 4x squared. So we notice that that's a perfect square. The last term is 9. We know that's a perfect square as well. And when we look at the sign in between them, it's a subtraction sign. When we have that, each of our terms are perfect squares. Both terms in our binomial are perfect squares. And the sign in between them is a subtraction sign. Then that gives us the difference of two squares. Okay? So our binomial is of the form a squared minus b squared. So that means when we factor this, we can use the rule a minus b times a plus b. So we could take our binomial, our difference of squares, difference of two squares, and factor it into this form, a minus b times a plus b. So all we have to do is figure out, well, what are we squaring to get 4x squared? Well, I'm squaring 2x, that's going to be my a value. What am I squaring to get 9? Well, I'm squaring 3, that's going to be my b value. Then 2x, that's going to go in for my a. 3 is going to go in for my b. So my factored answer is 2x minus 3 times 2x plus 3. And this is our factored answer for 2x squared minus 9. Now if we want to check this, let's take the 2x minus 3 times 2x plus 3. And if we FOIL this, we should get back the original binomial 4x squared minus 9, right? So let's do that. 2x times 2x gives me 4x squared. Outer 2x times 3 gives me 6x. Inner 2x times negative 3 gives me negative 6x. And last, negative 3 times positive 3 gives me negative 9. Now, those middle two terms, outer and inner, cancel out. So I'm left with 4x squared minus 9, which was our original example here. So our answer checks. All right, let's get into examples 2 and 3. So example 2, we've got x squared minus 1. Well, what are we squaring to get x squared? We're squaring x. What are we squaring to get 1? We're squaring 1, so that's our a, that's our b. So this is the difference of squares. So we can write this as x minus 1 times x plus 1 to factor. X squared minus 4 over 25. Well, x squared is a perfect square. 4 over 25 is a perfect square as well. So I can rewrite x squared as x to the second, right? So I'm squaring x to get x squared. What am I squaring to get 4 over 25? Well, I'm squaring 2 over 5. That's my b value. So I can rewrite this as x minus 2 over 5 times x plus 2 over 5. All right, let's look at examples 4 and 5. Example 4, I've got 81x squared minus 49. 81x to the second is a perfect square. So what am I squaring to get 81x squared? I'm squaring 9x. What am I squaring to get 49? I'm squaring 7. So that's my a, that's my b. So I can write this as 9x minus 7 times 9x plus 7. Number 5, x minus 1 squared minus 4. Well, what am I squaring to get x minus 1 squared? Well, I'm squaring this entire quantity, x minus 1. So my a value is going to be the entire x minus 1. And then what am I squaring to get 4? Well, I'm squaring 2. So I can rewrite this as, so that 2 is b, my b value. So I can rewrite this as x minus 1 minus 2 times x minus 1 plus 2, that's my a minus b, and a plus b. And then x minus 1 minus 2 gives me x minus 3, and then x plus 1. For number 6, I've got 20, z to the third minus 5z. Well, we don't have any obvious perfect squares here, but let's see what we can factor out, right? So 20z to the third, I know is 4 times 5 times z times z times z minus 5 times z. So what GCF, what's our greatest common factor that we could pull from here? Well, we've got a 5z and a 5z. All right, and what do we have left? We've got a 4z squared minus, and then we'll put a 1 as a placeholder there. So that 4z squared minus 1 is going to stay in our parentheses, and we can pull out our GCF, which is the 5z. So 5z gets pulled out. 4z squared minus 1 stays in the parentheses. Now we've got our difference of squares. So what are we squaring to get 4z squared? We're squaring 2z. What are we squaring to get 1? We're squaring 1. So this is a, this is my b. I'm going to bring down the 5z, and this is going to be 2z minus 1. That's my a minus b. And then 2z plus 1, that's my a plus b. And then number 7, I've got y to the fourth minus 16. Well, what am I squaring to get y to the fourth? I'm squaring y to the second, because a power to a power, I multiply. That's my a value. What am I squaring to get 16? I'm squaring 4. That's my b value. So I can rewrite this as y to the second minus 4 times y to the second plus 4, and this is my factored value here. Okay? All right, so this video was on how to factor the difference of two squares. We went through 7 examples. If you like this video, leave a like, a comment, and subscribe. I hope these videos are helping you guys. Check the card at the end of the video for how to factor trinomials where the value of a is not equal to 1. This is Nick from First Coast Math Clinic.